Okay, so robotics. So what exactly is robotics? So robotics is a branch of technology that deals with the design, construction, operation, and application of robots. So how I became involved in robotics was through the school's first robotics team. So first, the robotics competition, or FRC, is a competition which is run internationally by FIRST. They call it the varsity sport of the mind, and they say that it combines excitement of sport with the rigors of science and technology. Under strict rules, limited resources, and time limits, the teams of 25 students or more are challenged to raise funds, design a team brand, hone teamwork skills, and build and program a robot to perform prescribed tasks against the field of competitors. So each year, there's a different challenge related to this competition. This year's challenge was titled First Stronghold. The game was basically a castle defense game. It involved many tasks, including going over various defenses and shooting in boulders into the goals. As soon as the game started, there is a small autonomous window in which the robot goes over defenses and tries to shoot in the goals without any driver control. The rest of the game is in tele-operated mode. During that time, the robot's goal is to breach the defenses and to weaken the tower by throwing in boulders. So, I helped work on a computer vision enhancement to assist with shooting the boulder into the high goal. This enhancement worked with OpenCV and a small onboard Linux computer, a NVIDIA TK1. There are two main aspects to this enhancement. First, we needed to construct the ball shooting mechanism to consistently shoot the ball with the required force and pressure to reach the goal. Secondly, we need to create an OpenCV filter so that the reflective tape around the goal will be picked out compared to other objects. The boulder, which is essentially a golf ball, had to be shot into a goal which is approximately 8 feet off the ground. So, conservation of energy equations can be used in order to calculate how fast the ball needs to be launched at. The goal is situated approximately 8 feet above from the shooting mechanism of the robot. That can be converted to approximately 2.4 meters. As we know, the mass will get cancelled out once set equal to the kinetic energy equation. The gravitational constant is stable at Earth at 9.8 meters per second squared. Multiplying that out, an object 12.4 meters above the ground will have 23.5 times its mass joules of potential energy. The kinetic energy equation is kinetic energy is equal to 1/2 mass times velocity squared. By setting that equal to the potential energy equation, the masses can be cancelled out. So you get 47 is equal to velocity squared, and if you simplify that, you get a vertical speed of approximately 6.9 meters per second. With this calculated, the second step was to build a computer vision system so the driver could effectively track the goal and know when to shoot. So how color works in our eyes is the objects reflect some of the wavelengths of the color spectrum. So let's say an object reflects all of the colors in the color spectrum, that object we see as white. But if it absorbs all the wavelengths in the color spectrum, we see that object as black. So this is how we see colors in the objects. First, we started out by setting up the webcam to effectively capture images for the computer to process. So a green LED ring was added on top of the webcam to aid the computer with its task. So the green LED ring essentially added an overlay which caused the camera to only see this green color, so a monochrome of green. Then we could alter the HSV values on the computer so the camera would only pick up the reflective tape around the goal. So as a result, under perfect conditions, the camera and the gyro would only see the goal and would be able to precisely shoot the boulder or ball into it. So with all this calculated out, there's only one step left. We had to add the system to the robot. However, things did not work out as we thought they would. The ball, being a compressible object, which needed two sets of spinning wheels in order to be launched at the required speed because it needed to be kept at a constant pressure. So with that small footprint on the robot, as it was not able to possible to add that on while maintaining the ability to go over other details.